From the beginning of time, when man first learned that the sowing of seed in the earth would bring forth crops in abundance, farmers have been raising the crops that feed and clothe the multitudes. Today, those multitudes pose a problem that farmers of days gone by could never have coped with. So great are the numbers of people in cities who must be fed and clothed that the quantities of produce called for stagger the imagination. Foods are measured in thousands of tons. Fabrics from fibers measure in millions of yards. Thousands of people gain their livelihoods from converting the fibers into fabrics, the fabrics into clothing. Yet despite this crying need for sheer volume, competition dictates an equal increase in quality. The quality of clothing made from cotton fibers must be suitable for the finest stores. Wool must compete with, must outwear, outperform, be finer than man-made fibers. Where a few years ago the mere existence of fresh vegetables outside the regular growing season would have been looked on with amazement, today only the finest, crispest, freshest vegetables are acceptable regardless of season. So too the finest cuts of meat. Satisfying the needs of these millions upon millions of people is a job that is making the successful farmer become one of the most efficient men in the world. And a host of new steel, field, and farmstead machines and systems are now available or will soon be available to increase farm productivity and make the farmer's job easier and more profitable. Some show undeniable potential. Others must still be weighed in the balance of long-term operation. Equipment applicable at one farm may be irrelevant or extravagant at another. But with this new equipment, each farmer can fashion his own pattern of efficient, profitable operation to meet the needs of tomorrow's population. For example, no longer are there enough farmers to justify manual labor. Only multiple plows will solve the problem of turning the earth. Relatively few farmers produce a plenty. And without this fabulous agricultural production, the affluent society would be only a dream. Planting and fertilizing can be done in one operation, and aware of mistakes of the past, the farmer of today knows full well the importance of soil chemistry. He therefore uses special fertilizer formulas to maintain ideal soil balances. Concentrated plant foods can be delivered to the farmer ready to impart soil-enriching chemicals to maximize crop yields. And whether injected just beneath the soil surface or sprayed on, these fertilizers are applied with high-efficiency equipment. As the crops grow, the most efficient method of applying insecticides is the one that will do the biggest and best job in the least possible time. And when the plants are ready for harvesting, they are all ready about the same time. For instance, in harvesting sweet corn in the numbers called for by the nation's markets, adequate labor-saving machinery is simply a necessity. The same is true of field corn, which is made into breakfast cereals and feed for the animals and poultry that give us our meat and milk and eggs. The corn husking champion of today is a machine that not only picks the ears and separates them from their stalks, but also shells the corn free of the cobs, discharging mountains of golden grain. The same is true in the 1,000-acre wheat fields, which have given our Great Plains states the nickname breadbasket of the world. It makes no difference what the crop is. Peanuts to be made into jars of butter or simple cooking oils, or even to feed to elephants at the circus. Broccoli in such quantities as to meet not only the demands of seasonal supply, but enough to freeze for use throughout the year. Even the lowly potato, without modern labor-saving machinery to harvest it, could only come to market at prices far beyond the ability of the average man to buy. But great as the mechanization of field operations has been, the use of steel machines and buildings to handle and store the products of the field represents an equally exciting change in operation of the modern farm. Here, for instance, is the farmstead of a beef producer who uses storage units capable of holding all of the crops from 1,200 acres. A farmstead so automated that this farmer is able to raise all of his field crops and convert that feed into 2 million pounds of beef with the help of only 2 men. The flip of a switch selects, measures, mixes, and delivers a blend of chopped hay, silage, ground corn, and protein supplement in exact amounts necessary to produce the highest quality beef in the shortest possible time. And everything you see doing this is made of steel. There is, of course, considerable variation in the Farmstead systems now available. Selection can be made from an impressive array of systems varying in capacity, degree of automation, and cost. Modern feed storage facilities can provide farmers with the combined efficiency of low-cost, ideal storage environment and rapid feed dispensing the year round. Many dairy farms of today look more like rural factories with their rows upon rows of steel feed storage structures. Storage and grain from the fields is blown into them by machine. Batteries of push buttons divert the feed into various feed lots to keep the cows at high production. Milking parlors approach the zenith of automation. Since cleanliness is of the utmost importance, all of the milking equipment is made of gleaming stainless steel. To avoid contamination, the milk is taken from the cows without contact even by air, passing through stainless steel tubing with glass inspection points, tanks, pumps, and cooling equipment, direct to huge storage tanks, where within minutes of leaving the animals, it is held at 40 degrees temperature with scrupulous cleanliness retained right up to the bottling plants. Swine raising is a highly specialized field. The meat of these animals, prized for its excellent flavor, also supplies a higher content of vitamins and minerals than any other meats. And raising hogs need no longer be a haphazard operation. Here is a miracle of modern efficiency, which brings into sharp focus the tremendous difference between farming of yesterday and farming of tomorrow. Under old methods, when corn was harvested, it was stored in open cribs, on the theory that the flint hardness of the kernels would defend them from the elements until the time came for grinding and mixing into feeds. The pressures of modern efficiency, the need to bring to those multitudes in the cities farm products of the highest quality at prices within the reach of everybody, no longer permit the slightest hint of casualness in farm operation. This man shells his corn in the field as it is being harvested. Then he hauls it into a huge grinder. The corn is then raised by augers to storage bins, ready to be mixed into scientifically blended feeds and fed automatically to hundreds of hogs at a time. The hogs themselves are raised in the finest environment man can devise. Big blower fans maintain a constant exchange of air, cooling this huge circular building in the summer, ventilating it in the winter. The feed mixture, delivered by a revolving arm, fills all of the bins in each pen on both levels in less than 10 minutes. And the appearance of these animals proves the value of this kind of an operation. Clean, healthy, an assurance to the farmer that all of the pork he produces will be of first quality, able to command the best market price, and an assurance to the consumer of getting tasteful, healthy meat, raised in the sanitary conditions which result in meat with high protein, vitamin, and mineral content. And the protein, vitamins, and minerals are there. Remember what we said about scientifically blended feed? Livestock raisers all over the country, dairymen, beefmen, pork producers, are using modern computer services to determine balance in their rations. These rations change from month to month as the animals grow in size, as variations occur in the source of feed components, and include computations which relate cost of feed to computed market returns at animal maturity. Then, as a very important extra, They maintain a constant variation of antibiotics in relation to animal type and size to assure immunity against disease. And the production of eggs has also reached the age of automation in modern cage-laying operations. Drinking fountains in each cage supply water needs, while feed bins orbit around the cages. Eggs roll out of the nests, tripping counters which maintain production records, and are carried on conveyors to candling equipment. Here is the only segment in the entire operation where human supervision is required. From this point forward, the eggs are sorted, cleaned, weighed, and packaged in a completely mechanized operation. The many-faceted role of steel is obvious even to the tin-plated cans used to freeze whole liquid eggs. Even sheepmen, who by the very nature of their operations are the least mechanized of all farmers, are backed by the most scientific laboratory operations. Laboratories which, through analysis of wool fiber, dictate every move of these rugged mountaintop gamblers from breeding to feeding, determine which bloodlines will make the best wool, and what effect the feed from different grazing grounds will have on wool fibers. So too, the harvesting of cotton has entered a new automated era, an era in which white mountains of cotton can be built in the fields by efficient, economical steel equipment and set in motion toward textile plants and ultimately the consumer in the cities. The list of steel uses in agriculture is virtually endless. It includes galvanized sheet of various gauges, types, strengths, and finishes, each for a specific application. Stainless steel, steel tubing, and steel fence and posts with unmatched strength and durability for uses such as hog, cattle, sheep, and poultry grazing. The creation of all of this equipment involves much more than the mere use of already existing steel products. Recognizing agriculture as one of their major customers, steel makers constantly engage in research to discover ever more efficient steels and more economical means of producing them to meet the needs of this tremendous market. Scientists in research centers are now able to vaporize steel, see how its atoms are distributed, and detect the presence of trace elements as small as 1 part in a billion. From this, they are able to produce pure metals for further study, suspend them in space to prevent contamination during the process, and begin torture testing. Laser beams heat the steel to its melting point in thousandths of a second. They even listen to the sound of steel under the stress of pressure, twisting, and heat, while a moving pen records the results for future analysis. From this kind of research, they are able to make new steels, samples of which are produced in small-scale rolling mills and forged on miniature presses. They are then cold-worked, heat-treated, quenched, pulled apart, broken, and dissolved. Only after this are they ready for practical field tests. This kind of steel industry research results in the long-term durability of the material, or in words more meaningful to the farmer, reduction or even elimination of costly, time-consuming, and annoying equipment breakdowns. Hand in hand with metallurgical research, experimental machinery is being designed by universities and manufacturers, all moving toward greater ability of the farmer to meet the needs of the constantly growing populations. Here, for example, are 2 new steel machines, one designed by the University of California, the other by a manufacturer in Salinas, California, the lettuce capital of the world. Under normal conditions, lettuce harvesting is back-breaking labor, requiring armies of field hands trained to select only mature heads. These machines, however, not only select market-ready heads, but remove them gently from rows in a manner which permits repeated harvests. Here is an outstanding example of cooperative research between steel producers, equipment designers, and geneticists. The tomato is one of the most difficult plants to harvest commercially, since it must be picked day after day over a long growing period. To be successful, a machine must be able to lift the plants gently, check the fruits for color and size, and remove the market-ready fruits. Many designs failed until geneticists developed a new breed of tomato with size and shape adaptable to machine harvesting. These tomatoes become ripe virtually all at the same time. As a result, one of these machines can harvest over 100 tons of tomatoes a day. A moment ago, we spoke of the problems of materials handling on the farm. One of the greatest of these is the movement of hay, from the mower to the baler, bales to the barn, and from the barn to the feedlot. Here is an experimental steel machine which is approaching the problem from an entirely new angle. Instead of baling, the cut hay is picked up, chopped to easily chewed fineness, and compressed into cubes which can be handled like any other feed. And what of the problems of the fruit grower? He waits for an entire season for his fruit to ripen. Then, unless an army of pickers is on hand, he can lose his entire crop. Here is an answer: a tree shaker. It moves under the trees, spreads a frame to catch the fruit, attaches itself to the branches, and presto, the crop comes tumbling down. Similar machines are being developed for the more delicate peach. So far, because of this fruit's propensity for bruising, this type of operation is only suitable for canning peaches. This same kind of advanced thinking is moving into the farmstead. Here is a new building design which harnesses solar energy to solve some key problems of hog raising, especially environmental problems such as proper ventilation in high heat and humidity atmospheres. This building has dual wall construction. An inner and outer layer of galvanized steel forms a chamber which collects the sun's heat to dry the air in the chamber. The dry heated air is then blown through the building, gathering moisture on the way and exhausted from vents at both ends of the building. Result: even distribution of solar heat, dehumidification of the pen areas, and low-cost, healthy housing. Although all of these advances do make a farmer's life easier, this is not the underlying reason for all of the research and experimentation. The real reason is that it is only through these means that the farmer can remain competitive. And it takes a pretty able man to run a farm today. He must first of all be his own man, a practical man, ready to work and learn. He must be a man of the soil, and yet part businessman. Even as he understands the workings of nature, he must be able to think and talk in the language of the bankers and brokers, agricultural engineers and educators, programmers, planning experts, equipment designers, and economists. He must understand them and help them understand him and his problems, because they rely on him for the intelligent judgment which is the seed of all agricultural progress. Yes, the farmer of today is quite a man. And it is the best of these men who have made possible the creation of industries like the frozen food packagers, given work to the thousands of food processors, canning equipment manufacturers, materials handling specialists, and who bring to our markets the variety and quality of food we enjoy at prices which, in terms of percentage of our labor dollar, are the lowest of any nation on earth. Even as planning experts make every effort to meet the needs of our rapidly expanding population, to build new roads, design new traffic control systems, devise new methods of transportation, and create improved housing, health, and sanitation facilities, it is the farmer who continues to meet that population's most pressing needs. By successfully applying advanced concepts of farmstead and field production efficiency, the farmer is helping to build for himself and for all of us that standard of living, indeed, that way of life, equal to modern man's abilities and aspirations. American Iron and Steel Institute is proud to recognize the contribution of these men to modern life, and is proud to be a part of that contribution. Proud to say that, in a sense, steel too is a farmer.